Hello everyone, welcome back to JD Science Prep. Today we are finding velocity using distance and time. So consider this video as kind of an intro to this. We will not be doing any unit conversions at all. Those videos will be coming up soon. So just quickly off the start, velocity is usually stated in meters per second or kilometers per hour. That's what we will be dealing with today. And since velocity is a vector measurement, it does require a direction. So I do have a video coming up relating to vector measurements and scalar measurements as well, so stay tuned for that. But speed is a scalar measurement, so it does not require direction, while velocity is. So you can almost think of velocity as speed with direction. It also says in order to find velocity or speed, we can just use the equation v equals d over t, where v is velocity or speed depending on what you're finding, d is the distance, and t represents time. A couple more words to take a look at here. We might come across these definitions as we work our way through this video. Instantaneous velocity, so that is just the velocity of an object at a specific time in that object's journey. And average velocity is just an object's average velocity or speed over a specified time period. So we have a few examples here that we will work through. We'll use that equation up above in practice. We'll see if we can make it make some sense. So number one, it says, if a vehicle is traveling down the highway and drives a distance of 130 kilometers in 1.2 hours, what was its average speed? So first things first, let's write down exactly what we know from the question. We know the distance, and we also know the time. So I'll just write that on the side here. Our distance is 130 kilometers, and our time is 1.2 hours. So let's just quickly realize here, our time isn't 1 hour and 25 minutes. So we don't have to do any conversions from minutes to hours. Our whole time is in hours, so we do not need to worry about that whatsoever. So let's take a look at that equation we saw up above. We have v equals d over t. And just quickly to point out, we're looking for speed because there is no direction in this question whatsoever. So let's plug in our values that we know. We know our distance, we also know our time, so we can just plug in 130 kilometers over 1.2 hours, and if we type that into our calculator, we are going to get an answer for average speed. So what you should get if you type it in correctly is 108 kilometers per hour. If you're worried about sig figs here, we can round that up to 110 kilometers per hour. Okay. If you're unsure about sig figs, go and check out one of my past videos relating to those. So we have a speed of 110 kilometers per hour. That was its average speed across its journey. Let's move on to number two. Number two, it says if a person bikes 2,500 meters in 125 seconds, what was the person's average speed? So again, let's take a look at what we have here. It looks like we have a distance. This time it's in meters. We also have a time, but it's in seconds. So let's write down exactly what we know. Our distance is 2,500 meters. Our time, is 125 seconds. And again, we're looking for speed. So we can just use that same equation, v equals d over t, and plug in exactly what we know. So we know 2,500 meters over 125 seconds. And we will type that into our calculator here and see what we get as a answer. And what you should get is 20 meters per second. If we are taking a look at sig figs, we can say that our speed, we'll write it in scientific notation actually, is 2.0 times 10 to the 1 meters per second. That just makes that 0 accurate. It is not a rounded 0. So that looks good to me. That's our average speed for that biker. So last example here, let's scroll down. Number 3, if a person is driving down the highway directly north, so we have a direction, at a velocity of 115 kilometers per hour north for 2.5 hours, how far did the person travel? So let's write down what we know. This time it's a little bit different because we have a velocity actually. So we have 115 kilometers per hour, and we were given a direction actually, so it's north. We also have a time, which is 2.5 hours. Everything's in hours, no conversions there. But we are looking for the distance, so we might have to do a little bit of manipulation here. So we have v equals d over t, but we're looking for distance. Let's multiply t up. And what we will get as a final formula to use is d equals v multiplied by t. So let's just plug in our velocity and our time. So our velocity, we have 115 kilometers per hour. And you know what? I'll include the direction in there. Multiplied by our time, which is 2.5 hours. And I'm just going to go up here. And we're going to get a distance of 115 multiplied by 2.5. We're going to get 287.5. And our units here, because we have hours on the bottom and hours on the top here, we're actually left with kilometers. So our unit is going to be in kilometers. So a couple things to discuss here before we finish up this question. First off, the question just asks how far did the person travel, so that doesn't necessarily mean that we have to include the direction. If the question instead asked for displacement, then yes, we would need to put the direction. But I'm going to leave it so that there's no direction here. It just wants the distance traveled or how far the object traveled. We also have to worry about sig figs here. So it looks like we have 2 in 2.5 and 3 in 115. So I would say that we can round this up to 290 kilometers. If you wanted to, you could include the direction, which is north. All right, that is all I have for you. I hope this video has helped, and please like and subscribe.